Hello, everyone, and welcome back to yet another episode of Masters of Code. Slightly special episode because for the first time we are having not one but three guests on our series. It's a series wherein we talk to technologists about technology and everything around it. Today, I'm happy to host Jonathan, Davinder, and Pratik from Gojek. Jonathan and Davinder are senior principal engineers, and Pratik is a principal engineer at Gojek. And we'll be discussing about design as the bridge between the human and the machine. But before we dive into the questions, I would really request one by one Jonathan, Pratik, and Davinder to introduce themselves and also talk a bit about what they're working on right now. And then we'll start with the questions from our side. Over to you guys.
Myself, Davinder Singh, and I'm having 20 plus years of experience in IT industry. I was earlier associated with multiple companies like Wipro, IBM Software Labs, Yahoo, and a couple of other companies. And I'm generally taking care here, complete infrastructure, platform designing in Gojek.
Hey, I'm JJ. I've been in the industry for about 19 years. I'm a game industry veteran, and now I'm in ride sharing. I have the pleasure of being the architect for the matchmaking, pricing, and supply tracking backends of Gojek. Basically, everything that manages supply and demand, and which we call marketplace.
Hi, I'm Pratik. I'm a principal engineer for the matchmaking group at the moment. We are essentially responsible for matching any customer request to a driver. Prior to that, I've been in like multiple startups and big companies as well, including in Mobi, Amazon, etc.
All right. Thank you, everyone, for talking a bit about what you guys are working on right now. And let's get into the questions around design principles, right? And then and design thinking. I remember that for almost 10 years, there are a couple of corporates and big companies who have been talking about, and I'm seeing in the startup ecosystem, design thinking in entrepreneurship, and I'm pretty sure that it is something which is applicable in all aspects of software engineering as well. So my very first question is, how do you think we can incorporate design thinking principle in software engineering while building the softwares?
I can maybe take that, right? Like we have one of the key things about especially backend engineering that we deal with is we don't really have direct user interaction. So it becomes very important for us to incorporate design thinking more here, primarily because we need to know like what's the long game, right? So essentially in design thinking, what you have is you have a empathize step, right? You have an ideation step, you have a prototyping, testing step, right? There are multiple phases when you think about design thinking, and it's important that each of these phases is handled like not in the traditional UI UX design thinking way, but slightly different and slightly tuned towards more of how it works. At least this is my view of, you need to slightly tune it to how it works from a backend API perspective, right? So for example, when you think about designing empathy from a backend API perspective, you don't really like directly go and talk to the customer about it, right? But it's still important that you have a good understanding of what problem we are solving for, right? What's the end game, right? And that really helps us connect the dots from what we are building now and how it will pan out in the future, right? And that's where, even backend engineers, senior engineers, especially being involved in the process of understanding the customer problem, be it like using the MOM test, right? Where you just ask about what the problem the customer has, right? Or just understanding what's the TAM, right? Total addressable market. It becomes very important for the backend engineer because they can then put the long game in perspective, right? Then you have your this next step is like define like what's the problem there. Perhaps backend engineers or engineers might not be that involved in the sense that what is these are just artifacts created, right? Like documentation or user story cards, etc. But even though like the backend engineers or any engineer is not creating them, it becomes very important that they're part of the process, say with the customer or the user team, user research team, etc. So that like there's a feedback to them from our perspective of what is feasible, what is not feasible, what is right from a long-term perspective, etc. Then again, you have the ideate phase, you have the prototyping phase, you have the test phase, and finally, like if you think about like Pawan Soni's Design Your Thinking book, right? He talks about a scale-up phase as well, right? So in terms of backend, also it becomes very important, like for us to focus on how do we prototype and how do we like enable prototyping better? Because I think one of the tendencies is to build for scale right from the start, right? And we need to like, step back from that mindset and say, hey, we need to apply more of, this mindset of having mocks or prototypes or, small scale versions of our services up so that experimentations can be unblocked, and then like focus on scale once these experimentations are validated. So that's how I feel like especially engineering teams contribute to design thinking, or how engineering teams can apply design thinking and be more lean and agile in terms of delivery.
I have a point of view on that that's a little bit different. When I think about bridging the gap between the human and the machine, right? I think, how do we think? When we talk about the design, we often think about like symbols or very pure architecture or things that evoke some kind of memory or concept that people can instantly relate to. And that kind of immediately grasping what a concept is about is also part of design for me. And what I find makes the bridge between that and software engineering is what we call domain-driven design, which is something that I try to apply as much as possible. When we talk about a domain, it means talking about the vocabulary that describes a particular problem space. So I'm in ride sharing. So what's my problem space? It's orders, it's customers, it's drivers, it's rides, it's routes. And thus, when I'm going to create an architecture or an API contract, I'm going to try to use data structures that are as close as possible to that. So I'm going to try to have one for orders, one for actors, one for the plans that the driver has going through their various routes. And if I'm able to represent those concepts using the symbols or the images that instantly come to mind when people are coming into the problem space, I find it actually makes it a lot easier to adopt. You basically want to break down the barriers to entry by removing as much of the mysticism of computer science that exists between the actual problem space as business people or lay people can think of it, and the algorithms, data structures, and APIs that we use. That's how I try to approach the problem and bridge the gap between human and machine.
All right. Thanks for kind of sharing that and also breaking it down to different aspects, like how you spoke about the backend engineering for that, and also about the domain-driven engineering. Domain-driven design. Look, Pratik, you mentioned about right from the beginning, build to scale is something which is in the back of the mind, and it's true that whatever you are building, irrespective of whether you're going to serve a great number of customers or not, people are always thinking about how to incorporate that in the thought process, that I have to take into account that this product or this system which I'm designing has to serve, if not millions, then thousands or hundreds of thousands of transactions it has to kind of cater to. So how do you, and then what are those design principles which you incorporate while building an infrastructure or the system, right, which can cater to those number of and those super frequent transactions, those deployments which can be handled?
Yeah, I will take this question. So we have thought a lot when we are building or design a new infrastructure for any application. So a lot of designs, and there is a different mindset on to when we are building an infrastructure. Now, there is 12 principle which we thought about, or which we have written down, and which we used to build or complete this infrastructure. The first principle which we used about the Go managed. So we thought about everything will be there is the Go managed. So it will be, we use the GK, Google Cloud, and their most platform, which is managed platform from the Google that we used. Then we simplify all the problems. So it is not like the complex tools we will use, and that tools make more complexity onto the infrastructure. So we make everything more and more simplify for the developers, so that they can come and just deploy their application. They don't need to think about anything about the infrastructure. Then we built around that everything as a code. That was our third principle, which we thought about, like we will use the Terraform configuration as a code, infrastructure as a code, everything as a code. So there is should not be anything other than the code, no manual intervention. Then we also thought about the immutable infrastructure. So where people will not upgrade in place upgrade should happen. It should be always change the image, deploy the new things like Kubernetes is there. In Kubernetes also we are thinking about rather than using the any OS, so that we should not have any dependency on OS. We should use the immutable OS on that. So that is our next principle. Then we thought about the automation. So we build everything around infrastructure. If tomorrow something happened to the infrastructure, how we will build everything? So everything will be a like a model with the automation. So we can build everything, the infrastructure layer, and whatever the platform we are giving top of that platform until application is not ready to deploy. So we use complete automation. Then we standardize the things, standardized tools like this version, this particular version, this particular tool we use. So we don't have means everything we standardize on that, like which things the developer needs, which things we will provide them, which version of the Helm, which version of Terraform will be used. So all the things we will mention. Then we keep it one source of truth. That is where we talk about the infrastructure. Everything is our GitLabs. So whatever is our the best thing is a single source of truth is GitLabs. Whatever is written there, there will be nothing like you can change, go in cluster and change it. That is the only for us one place where everything it is there. If you make any changes, change into the GitLabs, into the code, and it will be automatically deployed there onto the infrastructure. And we build our cloud platform as such a way it should be cloud agnostic. Like if we are using Terraform, we are not using any in-place cloud platform. For example, if you're using AWS, you have the cloud formation or any other tool. No. So we want to keep it something, it should be cloud agnostic. Right now, we are onto the one cloud, and we don't want to go for multi-cloud. It is not the requirement right now, but if it is a requirement, we can easily move that as well. And our major is business continuity. So how it will be happen, multi places, multi zones, how we can keep it, where is our backup, restore, all the things are in place. So we thought about all those principles when we designed our infrastructure and platform. And we also there is a plan for the failures. So we also deploy, so in which circumstances there can be a failure can happen, how we can recover from there. So that is also part of our design principle.
Just one thing, just to build on top of that, I think what Davinder talked about is really like the tactical steps that we as Gojek are looking at, in ensuring that we are ready for scale. And also the second, like to your point, like what really helps us focus on scale is not to worry too much about scale. Okay, like this is where I think having commoditized components or things that are standardized really helps. Wherein like there are certain patterns that we know for this shape of data or this shape of transformation that's happening, this type of transaction that's happening. This is the choice, that's the default choice. And this pattern really helps us, to be very fast in terms of prototyping and then building that. Like you don't really, that prototype itself can scale, right? Because there are standardized components that we use, standardized layers that we have already on top of which we build, right? So if you're thinking about like a very small startup, right, they probably don't need all these things, right? They probably don't even need the scale. They build for something really small, perhaps serves 1,000, 2,000 users till they get some traction, till they get some runway, etc. But for Gojek, right, it's important to balance between, like, one of our core cultural principles is to be a scientist, which means that we have to rapidly experiment, try out new things. But at the same time, like once we experiment, the customer also has an expectation that, it will work at scale as well, right? It will work continuously. It will be available for others, especially in a ride hailing market. Word spreads around with the drivers, etc. Right? Hey, this new feature came out, didn't you get it? That type of thing. So that's why, using these standardized layers and standardized components really helps us be very fast in building these prototypes and also ensuring that these prototypes can scale.
Just to follow up to that, look, good that you mentioned about something specific with respect to Gojek, because while there are design principles, which Davinder mentioned, you guys have very, I'll say, in depth incorporated to build this infrastructure which is scalable. But without following these principles, also it was possible, and then there were scalable systems and infrastructure which were being built. So if I have to point out, like, what are those certain components, or very specifically certain functions wherein you feel that following these design principles has helped you build more robust and scalable infrastructure or systems, what will be those? Like, if I have to point out
Each
just few of
architect or
those.
each senior engineer you talk to will have a different variant of answer for this question. My personal feeling is essentially this was captured in this book called Accelerate also by Neil Ferguson. You capture like 3 or 4 metrics that is important to you. Like, for example, you have a lead time, how quickly your feature goes live. You capture your MTTR, which is mean time to recovery. You capture your CFR, change fail rate, right? And you capture a deployment frequency, which is the throughput, how quickly you're deploying things. My feeling is if you handle these 4 key things, right, all these other things fall into place. Like, there are different ways to achieve what Davinder, or what the tactical steps we talked about that applies to us, right? And there is no one single true answer. But personally, what I feel is if you stick to the point of sustainably delivering value to customers incrementally over time, all these things fall in place. And therefore, the 4 metrics that I talked about really helps, put you in that direction. Right? Essentially, like, if you think about deployment, tracking your deployment frequency and how quickly you can deploy. As soon as my change is ready, can I push it out to production without having any manual work to go into the production VM, change some configuration, which is where like the immutable infrastructure or managed configurations in a VCS, etc. comes in, right? That's like a implementation detail of this principle. Or if you want to have like good change fail rate, how do you track that, how much time you're failing, which is where Kubernetes really allows us to track. It will automatically do a blue, green, etc. That comes in. So essentially, these are all like ways to implement these like 4 key things. But like the answer varies. Like each individual senior engineer you ask, they'll have a different variant of that answer. One principle that we apply, again, this is a tactical step to achieve what the 4 strategic things that I talked about, is we always shoot for, even like when we, at least in my teams, like when we shoot for load testing or whatever it is, right, we aim for proving correctness of horizontal scalability. Like, we don't really need to say production traffic comes in and our system needs to work, because we have spikes. Like today what is X, tomorrow it could be 10X, right? So we need to be like thoroughly prove that our systems can horizontally scale. That is, you add more VMs, then the throughput that your system can handle increases over time. Like with the more, obviously it won't linearly increase with more VMs that you add, but one of the things that we try to ensure is that we have proven that our systems are horizontally scalable.
Got it. So now, I want to move to something which we had discussed while in the beginning of our conversation, was about the scale, right? And then building systems. And then here the question is, because Pratik, you did mention about the backend systems, right? Incorporating the principles. So, and then we mentioned about building for scale. But the question is, again, before thinking of scale, we should really check for the robustness and a lot of other pointers that have we checked on those. So why is it important, do you think? I mean, why is very easy to answer in my opinion, but how is more difficult to answer here? That how to go about that in terms of making sure that the backend solution which you have built, right, is has to be tested and has been prototyped very well before I'm going to invest in scaling. Because how, what happened in the Gojek journey, right? When it started scaling, it scaled at and I mean, I think exponential is also something which doesn't define it very well. It was at a very rapid pace and it just kept on going, which meant that you have to invest massive amount of money. But at the same time, if you weren't sure about your backend solutions, then it would have resulted in something not very pleasant situation. So how do we go about that?
Look, I'm very grateful and thankful to the whole open source community these days. Like, scale up is like a commodity. All you have to have is that knowledge, right? It's like for most of the applications that you build today, like 10 years back, right, the amount of work I had to do to scale up and all these horizontal scalability, testing, building products that can really scale up was really, really hard, right? But thankfully to, the open source community managed solutions, you have your cloud infrastructure providers. Because of that, scaling is like not slightly, it's like big part of that complexity has been taken away from you, right? One of the key areas where scale becomes a problem or a bottleneck is the persistence layer, right? And today you have like persistent layers that can scale like to a very high degree without you doing anything. Like if you use one of the cloud infrastructures managed service, right? You just like then the problem is, are you aware of those things or not? So before there was like a very strong trade-off that you had to take between scale versus prototyping, and that phase, what I would say is, you use your lean analytics, right? One, the Eric Ries lean startup, you measure, you validate, you pivot, etc. These days I think there is the cost of building something that scales up is equal or as comparable to cost of building something that couldn't scale up back in the day, right? So now I think that problem majorly has been like abstracted out for you, how to scale. So all you need to know is like be aware of those solutions and how to apply them, and that is the key thing.
All right. My next question is about, with respect to working in a small team versus working in a big team, right? How does one develop a design or an architecture, which works for 5 people, which is a small team, versus something like a 50 or 100 team, 50 people? How kind of to go about that?
Okay, I think I can take this one. So to me, it boils down to the concept of cognitive load, which is how much stuff do you actually have to hold in your brain for things to work. So the more things are explicit, like the more you can rely on documentation, the more you can rely on established processes, the more your cognitive load goes down. The less you rely on documentation and the more it's just kind of like in your head, the higher your cognitive load is. So when you're in a small team, there's a lot of shared knowledge. People just know what the others know. They're aware of what everybody else is aware of. They're aware of what they're not aware of, and they're aware of what they need to communicate. And these communications can usually happen just by like looking to the side and saying, hey, are you aware of this? Do you know this? And solving those issues like that. When you're in a team of 50, 500 people, that kind of implicit, quick knowledge transfer doesn't exist. So you need to make a trade-off, right? Your APIs become more explicit. Sometimes they become less efficient. Sometimes you need to put much more attention into documentation and processes and stuff that feels heavy if you're in a team of 5 people. But these are the things that let everybody kind of move together towards the goal without losing track of where we're going, and that are really necessary in a kind of large scale software project. When you're in a small team, wanting to put in these perfect levels of documentation and so on might actually slow you down, because you might spend more time maintaining stuff that for real you could just transmit using a conversation. And your trade-offs between how explicit your design is and how self-documenting it is versus how efficient it is and how quickly you develop skews it in a different direction. So that's kind of how I see the difference between developing within a small team and developing within a larger one.
And JJ, just to add to that, can you tell, like, if a team is very rapidly growing, let's say right now it's a 5-member team, so how does that transition happen without kind of impacting a lot of things? Look, certain trade-offs will happen, certain things will be slightly messy, but still, if the transition is happening very fast, how to go about that?
I think, and this goes back a little bit to what Pratik said about metrics and so on, right? Like as your team grows, you start to figure out that the amount of mistakes starts to rise, the amount of missed communications, the amount of, hey, I don't know what's going on anymore, the amount of confusion, the amount of difficulty that people have solving features grows. And then at some point, someone who has leadership, it can be the team lead, it can be an engineer, someone has to step up and say like, hey guys, do we need to change our processes? And it usually starts in response to some kind of a mistake or miscommunication that would not have happened in a team of 5, but that starts happening in a team of 12, 15, and so on. And these, and as a response, as a retrospective to those mistakes, new processes kind of get put in place organically. So that's one way it happens, the transition. Another way it happens, this transition, is just as a result of teams changing and of team layouts, just the humans that are working on things being made different. My experience is that like the most a manager can handle is about 7 or 8 people. And once you start getting to 10, 12, it's better to start splitting things and having different smaller teams working on sub definitions of the problem. And the thing that happens when you start to have different teams is that you need to create interfaces between those teams, both software interfaces and just human communication interfaces. When you think about it, a Scrum is a human communication interface where people who are working on different aspects of a problem collaborate on it. And even at a higher level, a kind of monthly report where division heads talk about what's going around in their divisions is also an interface, but between teams. And as teams grow and get subdivided and more of these interfaces exist, you need more and more formalized ways of passing in the information. And that starts to look like reports on metrics, on OKRs, and all of the management principles that we all know and love.
All right, moving on to the next question. And this is about engineers, because look, in silos, you can build the product, you can build a system, right? And then you can follow design principles, right? But in mid to large size companies, and then I will place Gojek as there, right? Rapidly grown and now has a massive number of engineers, big team. It's not possible for all the engineers to go and talk to the users, to kind of be in direct touch with them. So in those cases, how do you ensure that the design principles which you are incorporating, you are actually empathizing with the users while building those systems, while incorporating these design principles? How do you ensure that?
Look, I think since I brought up that empathy point, right, like your user might not necessarily be the end user also. So the user of your system is someone who is building a system that is using some that is directly customer facing, right? For example, Davinder's team here is infrastructure group, for which the user is perhaps not the end customer, but more like the product engineering groups, right? So while it definitely makes sense for Davinder and group to deeply understand what are problems of the end customer is there, right? But you also have to look at it like from a pyramid perspective, right? We need to like really understand what's our immediate users, who the stakeholder, right? Who is using our system, who is the one that benefits out of our system directly, and then how it connects to the larger scheme of things. It's important to understand both, right? And how, so the first cut is like when you are talking to your stakeholder about how they are using your solution, that also gives you a good insight on the larger scheme of things, assuming that they know their why, right? Or else you'll have to like prod that and deeply understand, why does this have to be this way? What is the reason for it? And you can propose some solutions based on that also, right? You need to know the end game, and at the same time you need to know how your consumers are using your tools to meet that end game. That really helps in building that empathy. You might not like always have the opportunity to talk to the customer directly, but there are like proxy mechanisms by which you can understand, and you can, one of the ways is like in Gojek, there's a principle that you have to dog food your product, right? Like you have to take the Gojek rights. One of the benefits that we have as Gojek as a company is we can use our own product very effectively, right? So if you are in like say Singapore, you're in Indonesia, you use the Gojek product, right? Say someone from an infrastructure team or someone from a non-core engineering team uses the product, they understand some issues that the customer might go through, right? And they report back. One of the key things what really helps us drive very high quality in our product is our own internal people telling like this, we faced this issue in our product. Like there's a group around Singapore users, and there's a group around Indonesia users. I am an avid follower of that group because you get a lot of good insights about what our internal users face directly as a problem statement, and it helps them build that empathy, right? It helps them build like what the customers are facing or what the drivers are facing. And then it also, one of the benefits that we can dog food our own products is it iteratively helps us improve our quality also, because when we face it, the motivation to have it solved becomes like 10x more higher, right? Instead of someone else facing. So we are our own customers, right? So we can then like develop deep empathy.
Okay, so just addition to this one. So we are work very closely with the development team, because they are our clients, and whenever they need any new infrastructure, any platform, so we are always in discuss with the developers to understand their requirement, and then we are hand over our infrastructure or to all the developers. So that's the way it works internally.
One way I know how I'm satisfying my customers is the conversation with my customer evolving? Like if 6 months ago, I'm getting asked, why am I not finding a driver in these circumstances? And now I'm still being asked, why can't I find a driver in these circumstances? And 6 months from now, I'm still answering the same questions. That means I'm probably not doing a very good job of serving my customers. But if the questions become more and more interesting, like, hey, can I get a driver with a child seat? I tried to get one, but it took me more time than I expected. That's a better question to answer than, hey, I tried to find a driver, but I couldn't. So it shows that I'm starting to solve the problems that were there before, and that we're moving into more pointed, more specific, more advanced ways of solving the customer problems. So I try to keep track of the questions that come back. And if they're moving in a direction, I see that as a good sign. If they're static, it's a flag to keep track of.
Got it.
One of the models that I use when I think about this question is like knowledge, right? There's what you know, there's what you know you don't know, and there's what you don't even know you don't know, right? And that's kind of classic, but it applies to the relationship with the customer too. When you're talking to a customer or when you're in their shoes, this kind of expands the sphere of knowledge of, oh, I didn't even know about this. This is often when you're going to run into new problems that you don't even know how to solve. And I find that's why it's important to keep that exposure. But once you start to get a little bit closer to the comfort zone where you're actually solving the problem, then that's where more kind of concrete and hardcore tools like analytics and ML model predictions and things like that come into play. What will often happen in a company is that there will be a high up executive who has a particular idea or a pain point, like, hey, I took this trip today, it was raining and the price was very low. Why was the price so low? And you can think, yes, that's a problem. We might need to lower to raise the prices when there's rain. That would be the immediate reaction. But maybe what you should do is see, okay, how is my supply demand curve looking when there is rain? Is it actually adjusting properly? Am I getting improvement over those metrics? So the conversations that you'll have with humans will kind of give you pointers into problem spaces, but the actual effectiveness of your solutions when you're solving those problems, I find are best measured with more concrete analytics.
All right. I think thanks for sharing that perspective, and thanks again. I would like to thank all of you for joining in this discussion. Thanks, Davinder, JJ, and Pratik. So guys, that was the discussion on design as the bridge between human and the machine. And we had 3 of the big proponents from Team Gojek join us and have a conversation on that. I'm your host, Alok Soni, and we'll catch up with you soon. Thanks, everyone.
Thanks
for having us, Alok.